I just wrote, let's just, I just wrote this on the non-random distribution of impact craters, the trifecta. With the recent discovery of the Nader crater off the southwestern coast of northern Africa at the Guinea Terrace, the question of the proximity of the craters to the edge of the continental shelf arises. Like the Chicxulub crater, the stratigraphic analysis suggests that the crater formed at or near the Cretaceous-Paleogene boundary approximately 66 million years ago. As a result, the authors considered whether it was associated with the Chicxulub crater as binary impact craters. Notably, the Boltish crater formed simultaneously and is also considered by Nicholson et al. As a binary or triple impact. However, again, also that, like Chicxulub, the crater... I gotta adjust this. Nader crater. Like Nader crater. Chicxulub. That makes more sense. I don't want them to think I'm saying Boltish crater is near the continental shelf because it's not. Because I'd link this to people. Randall Carlson. Robert Schoch, who I think would be find my research interesting and maybe be more willing to be honest about it rather than defensive. And then Graham Hancock, who seemed applicable, and Jimmy Bright Insight. Those were the 4 ats on Twitter that I linked this article to. But this is big. This is big what I'm about to get to in this article. That I just saw this today. So I thought I probably should just record as because I was literally about to start researching it. I was going to start reading this paper. I was like, wait a minute. I might as well hit record and then maybe I can set it up a little bit. So I'm basically saying that while it being at the edge of the continental shelf here is not relevant or significant, it's just odd alone. But when we see it also similarly with Chicxulub, it becomes a little odder. And then also considered to have formed in the same time frame of 66 million years is the Shiva crater positioned at the edge of continental shelf as well, making 3 simultaneous craters formed at the edge of continental shelf. More craters. I hope people look for these craters by the name More craters, because I mean more like More, and I googled it just for lols to see what came up. More craters. Did you mean moon craters? So there's no like, it's just confusing. But if you just take away craters and see like what's more. More is intentional misspelling of more. Yeah, that one. With more craters. They are not the only craters found near the edge of the continental shelf. Chesapeake Bay, Tom's Canyon, and Montagne. Montagne? Here they are. Notice 35 million years for those two. So these two are considered also binary. Then off the coast of San Diego are 3, which 30 kilometers for 2, exceed 30 kilometers in a third, diameter of approximately 12. Large craters. What's interesting about this one is they say timing of crater formation postdates the initial rifting and rotation of the western transverse ranges and appears to predate major right slip along the San Clemente and San Diego Trough fault systems. And then they dated to be approximately 16 to 18 million years ago. And then they say the craters lie entirely within the inner borderland rift. And I added emphasis here. Maybe I'm supposed to say that. I was just thinking that like this is not italicized or bold, and I probably should make the whole thing italics. But the point is that they lie within the rift. 3 craters within the rift. So it's just very similar to what I was just saying. How they're like on the edge. And then these craters, oddly, are all along the rift. And they formed intermediary to the processes of this geology occurring. That to me is strongly suggestive of a relationship between the craters and the local processes, both before and after their formations. And then the Woodley crater, the largest crater in Australia, which is here. The continental shelf, I didn't show it very well, is over here. It's about 150 kilometers from the center to the continental shelf. And I believe this is about 60 kilometers radius, 120 diameter. So it's not immediately adjacent, but it's still relatively adjacent to a point where I just pointed out. And then there's the Mjolnir. Fucking Thor's hammer crater. Which was formed 150 million years. And then interestingly, here it is, according to the coordinates. And then here's the fault line coming in straight, and then it bends off of its path to bend this way. And basically, it's almost as if it, like, the energy, it's like if you imagine a bumper, it like deflects off, but it pushes energy into the bumper, causing the energy to, like, maybe, this is what I was thinking, generally be funneled like down a bunch of river streams to a more like current, like a place where the flows can be funneled and focused and released, and it, like, in so bouncing off, it inputs energy into this region, which then causes it to funnel into some polygonal weak point, perhaps, and then that causes Thor's hammer crater, which just so happens to coincide with when this happened. So it's almost, again, like they're related, meaning it's like impacts wouldn't be related. That's the thing. That's what I'm pointing out, is none of this matters for actual theoretical impacts from outer space. They would not have these characteristics, but they do, which means they're probably not impacts from outer space because they have these characteristics. Interestingly here, 1, 2, 3, 4, 5, 6, it's got a hexagon, and then it's got this little side piece here, and then it's got a much more rounded peak. It's kind of, which is similar to Mount Gurnar, maybe. Also within, maybe this is very similar to Mount Gurnar. I don't know what the topography is like here. I have not looked into this, but just the fact that it has an inner shape that's maybe a square-like thing going on with an outer hexagon suggests maybe similar processes to Mount Gurnar, maybe not. I was also thinking like maybe these are like the electron blowing in a way, so like becoming excited and emitting, so it's literally emitting a particle straight out of the earth, a particle. So like I talk about that in other places, is how perhaps, and they say it maybe as just a comparison, purely as a comparison, is that the object that would have hit here is the same size, generally speaking, as Bennu, the asteroid. And I suggest, what if that's the particle that was emitted here? And so I believe that it's possible that can excite an electron emitting a photon, that the Earth emitted Bennu from an electron being excited that then is a representative of a macro photon, which is cool. And so there's that going on. So this maybe emitted something too, whereas Gurnar, like this would be maybe what I'm getting at is essentially like if it's an electron doing it, then it's almost like it's going to have a negative energy flow, like a negative imprint in a way where it's almost like the opposite of how Mount Gurnar formed, where the outer ring here is maybe I might be wrong in how this is. I assume downward, so like it's a divot surrounding it, a divot in a hexagonal pattern, whereas at Mount Gurnar it's an uplift. So this is maybe like a electric, like an electron related function, whereas Mount Gurnar is more of a nucleus function because it was emitted from the center of the earth rather than a electron becoming excited and emitting a photon. It was the nucleus emitting a proton. It's much different. And so the outcome is different, where we see the photon, the more negative, lower energy, more subtle energy emission systems producing almost like a negative of the positive. I'm fairly certain, as I'll go into a little bit, that that's going on once we go into this a bit. So as I mentioned, this goes this way straight here. I know I'm kind of cheating anytime I do this. I know it's like anyone looking at this who's gonna be like doubtful is gonna look at this thing and be like, well, what about like this angle? Like that's not, but like this is the angle it's coming in. So if I were to measure this angle, I wouldn't like measure, like I would measure from this coming in angle to this angle, and then from this angle again to this angle, perhaps, to get like a completed angle where it stabilizes at. So in this instance, I feel like where it stabilizes at is it's just an important characteristic. So like that it was stabilized going in that way. It was therefore propagating energy in that direction, and then when it turned off, even though it's turning off, the geometric outcome is more indicative of being reflective of this portion of the overall structure in some manner, where maybe that's not what's going on here. So here we see, let me pull up Google Earth. I don't know why it does that. Google Earth is a little better for looking near the poles than Google Maps. It's just a pain in the ass. And it also looks nicer. It looks a little more clean, maybe. Something about it. Even though I assume it's pretty much the same. So the crater is somewhere around here. It doesn't really matter. Something like maybe here, here. That's probably it there. That's probably it. Okay. And so I measured these angles. If we look here, this is what's important before I go into it. It's important just to see this, to know that this exists. So we see up here, and if we imagine that that crater there, I think it's right there, is part of this structure, like a polygon, then, and kind of just assume hexagon because it kind of looks hexagonal up here. And if let me pull up, just do this. It's not very accurate here, obviously. It's just too big of a region. I would need some more technical, precise method of doing this. I mean, if there's the crater, there's that though. So that's almost, let's just say it's generally in the range of 120 degrees. Cool. And then if we follow this general side, so pretty much there, and then maybe this general side, let's see. I mean, it's in the range for sure. If we were to say cheat towards that corner, that's 120 degrees. I'm also cutting off this here, but it does kind of look like it actually is here. This is not part of it. Maybe this is in part, but I'm not sure what's going on there. But it looks more like it actually has an edge here. So it's pretty safe to say that's similarly around 120 degree turn, and then it gets kind of it goes back over that way. Let's check this one out too. I might as well make that exactly that one again-ish. And then maybe try to just line it up with this side. Well, let's see, there's 120. So it is probably a little off from 120 on this side, all of this. It's so big, the region. Like, that's not right there. That's probably why. Let's see. Maybe make this bigger. That's pretty good, but this one's more like there. I mean, more like 120. Alright, so you get the point. It doesn't, that's not the coolest part of this. The coolest part is this. Let's say this comes down this way, maybe. If we look here, we see a really distinct, like, corner. So we see these structures. And then all these parallel lines that come up to this region. And if we look over here, I could have sworn there were more distinct features. I wish my mouse would work. I really saw, well, I mean, for sure I see, like, here. Maybe it was more over here. That's still part of this hexagon so big. Yeah, there it is. You can kind of see it more there. Although it says Google on it, which makes it kind of look like it's Google. There. Not quite as distinct as over here, but over here also we can see it still. And interestingly, it wraps around. So if we look over here, it wraps around. It starts to go around. This is interesting right there. I wonder. That's interesting. Well, that's actually pretty well in line with that. This is pretty well in line with the hexagon. Maybe over here, this. And then it wraps around. So it even, and you can see it wrapping here. I gotta remember that I cover part of the screen. Maybe I'll move back over here. And then there's the crater. And there's this, or wait, there's the crater, right? Whoa, is that not the crater? Is that the crater and that's not the crater? Oh my god. Whatever. Yeah, there it is. There it is. What the hell is that then, dudes? Guys, you guys are missing things. That's one too, for sure. That one almost looks like it has a fucking cool spiral to it. Whoa, that's cool. These things have like Thor vibes. The things I'm looking at up in the northern Russia region, this has Thor vibes. Thor vibes. All of it. So there's a hexagon there. I mean maybe not a hexagon. I noticed sometimes they're like 120 degrees, but then they they're like multiple shapes. Maybe reflective of like the portions that are visible at that elevation within a more complex structure, where like sometimes the four-sided object is the highest elevation object, so that one manifests on the surface. Sometimes the hexagonal one is dominant. Sometimes the pentagon one, etc. And so there's just different angles. Sometimes a 90-degree angle forms. So like a cube. And then triangle, 60 degrees. Or 30 degrees, maybe. So like, and what did I say? What did I say? Yep. So this one's considered to have formed simultaneous to Chesapeake Bay and Tom's Canyon craters, making two sets of three simultaneous craters that both sets occurred at, well, at least one of them occurred at a major, like, known boundary. I'm not sure if there's a change from 35.7 million. Maybe that marks the boundary also of something else. Geological boundaries list or something. Cretaceous, Paleogen. I'm so bad at this. Maybe it's related to the boundary between the Bartonian and the Priabonian. Meaning, like, it would be major Earth functions that are marked by multiple craters forming simultaneously, where the internal pressure building reached a sufficient point so as to cause the um yeah yeah reached cause some like noticeable boundary that we then look back in time and be like, oh, that's when this happened and that happened and that happened. Large polygonal structure. Yep. So here, this is interesting. It's also, there's many of these. I'm sure if someone really looked around the world, not just here but around the world, this is definitely a good one to look at. I should stop flicking that. But so I noticed this here, which immediately made me think of Mount Grenard, because Mount Grenard I've been staring at endlessly for weeks, months on end, probably 3 months, 4 months. It's been about 4 months since I really noticed Mount Grenard. So mind you, all of this advancement that the world will later notice has occurred in the past 4 months will be because of Mount Grenard. So when I looked at this and it makes me think of Mount Grenard, that makes me pretty stoked to think about the potential. But let's see. Snippets. Oh my god, it's why view. Maybe here. I probably just need to look at just a basic picture of it. So, like, look at this. Where is it? India vortex. That's what I called it. I didn't even like really know what it was. I was just like, whoa, that's a vortex. But right here, it's real distinct. There's this fracture line. Mind you, it runs exactly parallel to this. These two are exactly the same angle. Just saying. Coincidence, says geology. And so this central mountain has 4 radial ridges branching off from it. And this ridge comes out. So this one comes, these two are at 90 degrees relative to one another. And then the center is exactly east-west, and this one comes off at 120 degrees off of the center. And then this one comes off at 120 degrees off of the center. But then it turns so that it's 90 degrees off. So this later portion is 90 degrees off of this ridge, whereas it's 120 degrees off initially. And when it's 90 degrees off of this ridge, coming in this way, it's 90 degrees off of this fracture. And so there's a fracture that has a hexagon. Mind you, this is also, if you can kind of see it here, a hexagon. I'm not sure where exactly, but there's a hexagon of olivine gabbro that is at the center here, and then the outer hexagon is basalt. So there's different materials, and then there's a flow that occurred here from the central mountain seemingly to all of these peaks, all of these radial hills. They're really hills, but they're mountains. They're everything. They're microcosm of everything. But this radial ridge fed into this hump, this hill, this huge chunk that literally was so fed into being that it caused a detectable separation line that was parallel to this. So when I saw a similar feature here, and I measured it, and it's pretty close to 90 degrees off of the structures. I mean, mind you, these are kind of bending like more this way. It really does bend around and seem to follow this. So this is kind of like, it's like the same thing happening. It's kind of weird. I have not looked at this much. So that's where I'm kind of at now. What is really going on? In a sense, these impact craters are like blowout valves in the structure of the Earth itself that allowed energy accumulating in regions to be expelled through point locations. That's my interpretation thus far. Perhaps a very rough one, but still one that I believe captures significant details that are not yet described about the formation of these structures because we think them to be external impacts from space. Okay, what else? As there are two separate sets of trinary craters all on edges of continental shelf and both distributed globally and more locally. Really, there's three sets of trinary. I should point to the San Diego ones as the third one. These are not random and thus cannot be impact craters from outer space as traditionally viewed. Because there's literally no discussion of any of preference for where an impact hits. It just hits where it hits. It doesn't care. These things care. You see, that's the difference. Like they literally have a preferential way of doing it. Why would they be? I mean, this is a hexagon too. That's insane, dude. Wow. Along the coast, for certain, I will admit, they're not all along the coast, but I will also point out, like this one, like for instance, this one, perhaps some of the instances it can be explained by energy propagating in that direction, in the fracturing of the continents apart. So when the energy is flowing, it pushed energy in, caused a bloop, caused the Earth to pop, explode a little bit in that spot, and then there it is, and it kept going or it stopped. Mind you, the one over here is this one looks real interesting because you can tell. Let's see. So here's the. Oh yeah. Wait. Where? Oh. Interesting. So maybe it's related to Iceland. Because, so like, this is kind of cool looking at it from this angle. I kind of like it. Africa, Mediterranean. So the propagation of the wave came this way when Dwarka was attacked, which was positionally or somewhere around here, probably like, let's say here. This was closed up. Dwarka, maybe it was more here. Dwarka's right here. This region was just closed. How exactly that region closes up, I'm not quite sure. Maybe there's a little bit more. Like this for sure is up here. Madagascar is here, which then is filling in some, I think, along here. Okay, so it basically comes this way, comes this way, comes this way, the Atlantic is not formed yet, so it turns here, which is here, at Azores notably, which is also maybe also notably at Flemish Cap, possibly. Maybe there's a correlation between the two, although this one looks maybe more like it's over here, and maybe this looks more, if anything, like it would be closer to this stuff than here. And also I've heard that Flemish Cap was more here even and moved. I don't know. Flemish Cap is not the most researched place. It seems kind of boring, or people view it kind of boring, like mostly for oil. And yeah, I'm not, pardon me if I'm mistaken, people who rigorously research Flemish Cap. But so the energy went this way initially, but that's not related to this crater. Then it although we can get back to that, I guess. It comes this way, according to the video which I watched in one of the previous reactions. And then it comes through here, cuts through between here, to a point where an entire island is formed. I don't know what to make of Iceland. But maybe it's just like similar to like, why did Iceland form? That's what I don't know what to make of it. Why did Iceland form, and why isn't there like another Iceland here, another Iceland here? Like, what the fuck? I don't know. But let's go on. Let's just move past Iceland for now. Although it's a curiosity I'd like to look into more. Pardon me for not having more information. People who are more informed on Iceland and more geologists, like, because obviously I'm new to many things that I'm just, like, my plateau is just fucking falls off immediately for most information. It's just how it is when I'm newly exposed to practically everything I'm researching. So this comes along, and see, it does go pretty straight, man. It's hard to say where the fault line's going through here. But maybe it goes over. There's an island there, it looks like. So maybe it comes this way somehow. Some point it comes over more off of this path than over here, which maybe that's part of why this happened. Before I get too much on that, I don't know. I don't want to hypothesize too much. But then it comes straight and turns, which is when Thor's hammer. Maybe Thor's hammer is right there. What if Thor's hammer is like 50 meters buried under the exact center? There's this anomaly. Whoa. And then it comes this way. Okay. What's going on over here? Alaska, Canada. Okay. Seeing if there's some. Comes over this way, comes down here, Okay. So it turns around the polygonal. It takes the path of least resistance to go around this, like, actual body. Because there's, like, a like unified system that is more like a single system than it is with like neighboring regions, because it has polygonal boundaries that just naturally form according to energy flows on the earth. And so it comes there, and then it keeps going. But it also turns off this way, which is interesting. So it goes this way, and turns off this way. And seems to make a crater here, dudes. I don't know. Maybe I'm mistaken. I don't know what that is. But what the fuck? Why is that not? That's a crater, but that's not. Comes this way, which is also, maybe it's related to this. I wonder what. I don't know. And then it turns, like there's also another polygon, like another, it could have kept going this way, but the reality is there's a shape here. There's like a single structure that's more firm than the separation between the boundaries. So it takes the weak point path between them. And then it kind of stops because this is the end. Like it's just kind of running out of steam. I don't think it maybe did anything over here. Maybe it caused some, at least that I'm aware of. I'd have to look into like, this almost looks like Texas. Wonder if that's also part of a polygon right there. See, they're not necessarily just normal shapes. Like, they can be like hybrid shapes. It seems, pardon me for acting like I know what I'm talking about with this stuff. It's just a curiosity at this point. Just something I've started to notice with enough regularity. That looks almost like a cross type, like it had some sort of lensing effects in its formation process. This looks like a fucking swastika. At least part of one. Kinda. Not to be like, check out that swastika, people. It's like, dude, that shit predates Nazis. Stop fucking letting Nazis take something that's obviously not even theirs. The fuck is this? I guess same. Not trying to take things that are mine, maybe. I don't know. Pardon me if that's what's going on. Claiming some sort of source to it all in me. Oh, yeah. I am the discoverer. God's like, pardon moi. Just fucking right in front of the whole class. I'll teach you a lesson, boy. I don't know, man. But this made me think, what if there's something here? Like it's kind of like I was saying, a negative. That also looks kind of like a swastika. The reason a swastika would matter is because it's not just a swastika. It's a rotating energy, maybe. Like, that would make sense then. Like, if it's tailing off always in the same direction. I don't know why there would be these types of energies there. Although, if this is the center of a hexagon structure, some dude's face here looking at me. What up, bruh? Mouth, no, nostril, eyes, hair. Maybe some... or lady, pardon me. I don't know. They look like I even got some like holding something maybe. Could have some body parts in here, some scenery, something going on. Okay, where was I? Oh yeah, I was looking at this paper about Papagei. This one, because it's the same time. More. Let's go to it. Establishing the link between the Chesapeake Bay impact structure and Papaguy. Wait, what the fuck did I just do? Pop. I guess I might need to open it directly. Papaguy. Let's get to discussion. Major and trace element chemical compositions of the Chesapeake Bay target sediments in comparison with the Exmoor Breccia crater fill. In comparison with the shit in the crater and tektite data, do not tektite that there's tektites related suggests there's ether flows related. Ether flows. Which maybe would make sense then why there's a hex or spiral swastika looking shapes on the earth in that region where Papaguy is. I don't know. Just some thoughts, pardon me. Do not allow us to uniquely identify a specific source for the North American tektites. The similarity between the tektites and the Chesapeake Bay crater rocks is the greatest, within a factor of about 2. Does not give note that the sodium content of at least the Bedia sites is higher than that of all analyzed sediments, necessitating source materials as rich in sodium as a precursor to the tektites. Sodium. I feel like that's a common alchemy concept. Let me just real quick see what alchemy says, because I was just talking about ether. Which, so if I think I gotta go watch the show with my family. I'll just be a few more minutes. Walk through for sodium. Sodium. It is an ion. Positive ion. Missing an electron. Okay. Electricity plus fire plus salt equals sodium. Pardon me, that's not the most. I'm thinking more like I wanna read someone discuss the alchemical thoughts on sodium. I guess I'll just be back. I'll return to this after we watch Andor. At least one episode. I'm probably just one. Unless it's good enough where I'm like, alright, fine. Like I'm fucking breaking barriers down. Walls are shattering. Fucking new paradigms. Who knows? Wanna watch that show? Shit. Okay, sodium. Let me see if I can find sodium. Sodium. in specific. I was thinking like how they talk about mercury, but that's not the. That's probably not the best source. It's too not. It's not like central to alchemy sodium, I guess, where I can just Google 22 key alchemy symbols and their meanings. Like mercury and sulfur and fire, like that kind of thing. If I put those words with alchemy, I'm more likely to get something that was actually useful. So I guess sodium is just not as prevalently discussed. That's is what I was getting at. Meaning it's probably not as central to alchemy, but still a major concept, obviously. I don't have time for this. Sodium. Single element. So that's. Oh. A single element. That's interesting. Just that they suggest it's a single element is interesting because I wouldn't be surprised if it was like like I was just getting at, like this hexagon here is kind of like a single unit, like chlorine, where maybe this hexagon over here is more like sodium, but it's not just like many of them. It's only like this, which is showing two lumps that form the shell of the body that then form the molecule of sodium chloride, but it's really a single unit that are then bonded through points of energy, like say, like here, Neater Crater was bonded to South America through these little tab things, presumably. I guess. I don't know. Maybe that one was up more up for here. I'm not sure where that exactly ended. Maybe over here. And this went up here. I don't know. It looks like it goes here, like across this way. Maybe I could follow this one there. But then it comes more like up this way where it could be all, like this could be all the way over somewhere here. Like I guess here. Probably here. It's probably right here because this is where, if you look closely, ignore this. This comes around. Notice the mountains here. This comes around. This shit got added on top afterwards. Like when this shoved debris, this exploded. It sent debris this way. It caused these chunks to break off. It caused this island chain. It caused this, and it basically came through, though, in a very smooth curve of a golden ratio curve. And so it very much suggests that this was added on. And the actual curve is here. And then it ends exactly there. So that's really probably about where Nader Crater is. Around here. So it'd be interesting. Maybe there's even another crater, like the bond broke on both sides. That's kind of what I was thinking initially. Like if you imagine they're pulling apart, but they have like rubber bands connecting them that are like subtle energies that are at nodes, like the Nader Crater and one over here, to the point where maybe they both blow up simultaneously. So it's possible that could be happening. So it's possible there could be a crater there. So it's possible we could check, and not to mean that if there wasn't, that it would be proof positive I'm wrong, but if there was one, it would just strongly and suggest that there's something to this. I don't know. There's probably a lot of seismic data out there that maybe could be looked at closer in specific places along the edges, especially bends and points, for just to see, because I know a lot of the craters are like on the edge. Is it a crater? Isn't it a crater? Oh, who knows? Okay, I gotta go. I'll be back. I'll be back.